All right, here we go. Review for the Unit 5 Part 2 test. Number 1, state the degree, type, and leading coefficient. Now, the most common mistake here is to say the degree is 1 and the lead coefficient is -2. Many of you did that in the last test. The problem is this is not in standard form. So you have two choices. You can just find the highest degree. Whoops. And put a box around it. And then you see, oh, it's a square and lead coefficient is -8. Or you can literally rewrite it, which is not really necessary for what you're doing in this problem, because after this, all this doesn't really matter. So it's up to you. You can rewrite it in standard form or just find the highest degree. Now in B, it's already in standard form. It starts off with a cube and goes to a quadratic. So the lead coefficient is -4. Moving on. So number 1, we always want to look for the GCF first before we do any factoring. Okay? And since we're dealing with cubes here, remember our SOAP, we cannot do this right now because 3 and 24 are not perfect cubes. What are our perfect cubes? 1, 8, 27, 64, 125, and so forth. But if we take a 3 out, that's going to give us 1x cubed minus 8. 1 and 8 are both on the chart. So at this point, we use our SOAP formula. It's very simple. Okay, it's in the notes. Remember, it's A minus B. Okay, so you just take the cube root of each item. So in this one, the cube root, don't forget the 3. The cube root of x cubed is just 1x. And then 8 cube root is 2. I'm not going to worry about the sign right now. Then we square the first term. So 1x times 1x is 1x squared. Then we multiply a times b. So that's 2x. And then we square the last term. So 2 squared is 4. And then we deal with our SOAP. Same, opposite, always positive. So I already put the negative in, so same, opposite, always positive. And there you go. Next one, 2 and 54 are not on the list, but we can take a 2 out and get 1 and 27, which are on the list. So we start with the 2, don't forget that. We have our small parentheses, cube root of x cubed, cube root of 27. Our big parentheses, we square the first term, we multiply the terms, and we square the last term. It's really that easy. And then we do our SOAP. Same, opposite, always positive. So same thing, we had a plus, we're going to put a plus here. Opposite, always positive. And that's all. Okay, divide. All right. So x minus 4, if we set that equal to 0, we get x equals 4. That is the number that goes in the box for synthetic division. We have to look at, once we start with a 4, first off, make sure it's in standard form, descending order. And once we know it is, we have to make sure we have a 4, 3, 2, 1 constant. We do. So we have no zeros to fill in. So lead coefficient, next coefficient, next coefficient, next coefficient, and the constant. So we drop the 1, we multiply by 4. We add, 4 minus 1 is 3. We multiply, 4 times 3 is 12. We add, careful with signs. We multiply by -4. We get -3. And then we get 4 times -3 is -12. That gives us 0. Now, with divide, that means we just need our final answer, okay? And that is, since we start with a 4, then this 1 is going to have an x cubed. Then we would go backwards. 3 is going to have an x squared. Negative 1 is just going to have an x to the 1. We don't have to put the 1 if we don't want to. Minus 3 as our constant. And there's no remainder, so we are finished. That's it. Now notice, it says divide. It does not say factor. It does not say find all the factors. It does not say find all the roots or zeros. We're done. Read the directions. All right, this is x equals 3. So we put 3 in the box. Now we're starting with the 4. Okay, so I have a coefficient for my quartic. I do not have a cubic. I'm missing a cubic. So I must put a 0. Then I have my quadratic. I have my linear. And I have my constant. The most common mistake here is to put 2, negative 12, 2, negative 5. And leave out that 0. Drop the 2. Multiply by 3. Add straight down. 6 times 3 is 18. 18 minus 12 is 6. 6 times 3 is 18. That's 20. 3 times 20 is 60. And that's 55. Don't worry if we have a remainder. Don't worry if it's large. It could be 3,482 as a remainder. That's okay. Remainder does not mean you made a mistake. Now, I started with a 4, a quartic, so the 2 is going to go in front of an x cubed. The 6, which is positive, goes in front of an x squared. The next 6 goes in front of an x to the 1, or just x. The 20 is my constant, and the 55 is my remainder. So I write the remainder over the original divisor, x minus 3. Pay attention to the instructions. Substitution means you're just plugging a 4 in here, 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 and here. So I'm going to use my calculator for that. So I'm going to come here, and I'm going to clear this out. You could also use Desmos. I'm going to put 5x to the 5th minus 18x to the 4th minus 7x cubed minus 10x squared plus 28x, and make sure you double check as you enter these that you're hitting them right, minus 10. Now I'm just going to go to my table and look up 4. If x is 4, y is 6. That's my answer. I put in 4, I get 6. Substitution for number 6. Same thing. Bring it over here. I'm going to clear out what I have. Negative, remember use the gray negative key if you're using the calculator. 6x to the 4th plus 3x squared plus 10x plus 2. Go to my table. I'm going to look up 2, negative 62. Not too bad. Number 7, possible, okay? Remember, if it says possible, as soon as you see that P, think P and Q. Only if you see possible. If it says list all the real zeros or list all the zeros or all the roots, don't give the possible zeros. That's just the first step. So here's P and here's Q. So we're going to be doing 12 over 4. So that's 1, 2, 3, 4, 6, 12 over 1, 2, and 4. Now this requires a little bit of work, just time consuming, it's not hard. So, first off, all the numbers on top divided by 1 are simply all the numbers on top. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now, it's not as bad as it looks because now we're going to divide them all by 2. Well, 1 divided by 2 is plus or minus 1/2. And all the rest, and then 2 divided by 2 is 1. We already have that. Then we need 3 divided by 2. So plus or minus 3 over 2. 4 divided by 2 is 2. We got that covered. 6 divided by 2 is 3. We got that covered. And 12 divided by 2 is 6. We already have that one listed. Now we're going to divide everything by 4. So we need 1 over 4. 2 over 4 is 1/2, which we already have. 3 over 4, we need that one. 6 over 4 is 3/2, we already have. And 12 over 4 is 3, we're done. That's it. Not hard, just time consuming to make sure you get every one of them. All right, this one, 6 over 3. So 1, 2, 3, 6 over 1 and 3. So first off, all those numbers on top over 1. Now all those numbers divided by 3. So plus or minus 1 over 3, plus or minus 2 over 3. 3 over 3 is 1, we already have that. 6 over 3 is 2, we already have that. We're actually finished. All right. 9, turning points. All we need to look at is the highest degree. These are already in standard form, so I need that 5. Turning points is 5 minus 1, so 6. Or, if I actually subtracted, that would be 4. Wow. Wrote subtraction, brain added. It happens. So 5 minus 1 is 4. Here, we have 8. So 8 minus 1, let's see if I can do it right this time. 7. Didn't even need my calculator. And remember, that's the maximum turning point. Doesn't mean it will turn that many times, just the maximum. All right, matching. First off, this one right here is going to be either a cubic or a fifth or a seventh, but most likely a cubic. But it could be one of those other ones. So right off the bat, A is a parabola. We don't have any parabolas. Okay? We know a parabola looks like this or like that. A is out. Smart test taking skills, get rid of that. B is a cubic. C is a quartic. And D is a quartic. All right. So our only choice for this one is B. It is a negative cubic. If it was a positive cubic, it would have looked like this. Now, B is done. We have C and D. They are both quartics. C is a positive quartic. And remember, that's usually in the W shape. And D is a negative, which is usually in an M shape. But since they don't always have to be even, this one is D because it is going down. The end behavior is both going down. All right, moving on. State the multiplicity and the function, if the function will bounce or cross. All right, well, the multiplicity is the degree of the binomial there, so it is 5. Odd numbers cross. We in class have said through a lot, but you might have used this term, so that's okay. Cross or through. It crosses through the point. 4 is a multiplicity. It's even, therefore it's a bounce. All right, let's get out of the watermark here. 12 and 13. Determine the end behavior. Now remember, when it comes right down to it, all of this stuff really doesn't matter. So you can literally just take your calculator, go to y equals, clear out what you got, and put in negative 5x to the 5th. And you can do this in Desmos also. And then hit graph. Notice, okay, what that's doing. I could even go back in here. Watch what happens if I change this to a 3. Pretty darn close, huh? I could change it to a 7 also. In other words, it looks, wow, I don't know why I did that. In other words, it's basically doing this. So again, as x approaches negative infinity, which is out here, in other words, as I'm going left, what's it doing? It's going up. Where? Towards positive infinity. We don't have to put a positive. And then as it's going right, as x is going right, what's it doing? It's going down towards negative infinity. All right? Now, we just determined number 13, well, number 12 was a 5, but it looked just like a 3, correct? So number 13, I could graph this, but I should have an idea from looking at number 12 that if it's a positive version, it's going to do something like this. I don't really care specifically right now because I'm just looking at the end behavior. But once again, I could go to Desmos and just real quickly, and even the 5 doesn't matter, or 3. I could just leave it at 5, but I'm going to put in 3x cubed. Graph. Okay? The point is, even the 3 doesn't really matter. I'm just worried about the end behavior, not the overall shape. So therefore, what's happening? As I'm going left, as x approaches negative infinity, what's happening to the y? It's going down towards negative infinity. And as x is approaching, going right towards positive infinity, we are going up towards positive infinity. Okay? Number 14 and 15 are both even. 14 is a positive even. That is usually a W shape. Okay? So we really don't have to think about this too much. This is going positive, positive. It doesn't matter whether we go left or right, it's going towards the sky. Number 15 is a 6. It's still an even. So whether it's an M or has an extra, dip in it, it doesn't matter. It's going to be going down towards negative infinity because even exponents, the highest degree is even, they go in the same direction. So a 6 is going to go towards negative infinity. Again, you could put in real quickly just this into the calculator or Desmos, and you're going to get your end behavior real quickly. Number 6. Use the graph to determine if it's even or odd. All right? Well, since they're both going the same direction, all right, and they're going up in the sky, this should be number 16. That means it is even. It looks like it's probably a 4, could be a 6. It's definitely not a 2. The lead coefficient is positive or negative. Since they're both going towards the sky, it's positive. How many real zeros? Right there and there. Remember, zeros are the same thing as x-intercepts. So that's 2. Moving on. 17. We have this shape. Now, obviously, this is not a cubic because it has more, dips and hills. But it has the basic shape of a cubic like this. So you have a couple choices here. You could go back to the cubics we just did, and see which one matches that shape. Whoops, wrong page. Okay, right here, which means it's a positive lead coefficient. Or again, you have Desmos or a calculator. You take your calculator and say, I want to see what this is. And since you have a guess that it's probably, you know, a fifth, doesn't matter. You just put in x to the 3 or the 5, doesn't matter, and you're going to get positive. Okay? So what is that doing with our graph? First off, we know it's odd. Most likely a 5 or a 7. The lead coefficient is positive because that's the direction it's going. How many real zeros? 1, 2, 3, 4, 5. So it is a fifth power. All right, factor the following polynomial function given one of its factors. So this is like we did on the first page. But notice it says factor and it says write in factored form. So we'll talk about that in a minute. X equals 4. So we put 4 in the box. Our highest degree is 4, 3, 2, 1 constant. We're good to go. So it's 1, -1, -13, 1, and 12. Drop the 1, multiply. Now, here's the other thing. Remember, since it says that this is one of the factors, we know right here we should get a 0. If we don't get a 0, we made a mistake. It happens. Go back and check your math. 4 minus 1 is 3. 4 times 3 is 12. That's -1. Might be a place where we might have made a mistake right there. That's -4. Add to get -3. -12 makes 0. Since we started with a 4, this 1 is my x cubed. Then the 3 goes with x squared. Then x, -1 is -1x, and -3. You have a couple choices here. You could do synthetic division again. If you were going to do that, I would put this in the graphic calculator, which you should have done anyway. Okay? And find the other zeros and done another box. Or you can try factor by grouping. So here I'm going to take an x squared out and get x plus 3. I know I can cheat and put x plus 3 here because I need that, which makes this -1. Because this divided by -1 gives me x plus 3. I'm going to hook these two up. So it's going to give me x squared minus 1 and x plus 3. Now, something I forgot to mention before that I usually say all the time is, if you're going to be writing this in factored form and you already know this, you should come down here immediately and write that as your first factor. Because that is one of the most common mistakes, is leaving that one off. Okay? If you don't have 4 binomials down here, there's something to look out for. Now, we're almost done. This is one of the easiest things to factor. It's a difference of squares. You don't put it both plus. And then the x plus 3. So now we're done. But again, most common mistake here is just to write these 3, and that's not the answer. It's all of these. All 4. Hey, and look at the directions. Also state the roots. So we need to write each of these, solve them for 0. So x minus 4 would give me 4. X plus 1 would give me -1. X minus 1 would give me +1. And x plus 3 would give me -3. There are my 4 zeros, my 4 roots. But again, make sure you pay attention to what the question is asking you to do. It may not be like this in the test. All that might be in the initial instructions. Read the directions. All right, now we're going backwards. We know we have x equals -2, x equals 1, and x equals 3. So what are the corresponding binomials? Well, if we solve for, make it equal to 0, that's going to be x plus 2, x minus 1, and x minus 3. Now we're not done. We want the polynomial. This is factored form. So now I'm going to FOIL or multiply or double distribute, whatever you want to say. I'm going to do these first two here. So x times x is x squared. Then I'm going to get negative 1x on my outside. My inside is going to be 2x. And last is 2 times negative 1. All that times x minus 3. But I'm going to join like terms first. So x squared, 2x minus x is plus 1x minus 2 times x minus 3. Now I'm going to distribute the x through the trinomial. So x times x squared is x cubed. X times x is x squared. X times negative 2 is negative 2x. Now I'm setting the negative 3 in. Negative 3 times x squared is simply negative 3x squared. Negative 3 times x, you're literally just going to write the negative 3 and the x together. And negative 3 times negative 2 is positive 6. So when I combine like terms, there's only 1x cubed. 1x squared minus 3x squared is negative 2x squared. Negative 2x, negative 3x is negative 5x. And the 6 is just by itself. There's my answer. Okay, same concept, just working backwards. So I have x plus 3, x plus 1, and x minus 4. So I'm going to multiply these two first. That's going to give me x squared plus 1x plus 3x. That's my outer and inner terms like that. And then plus 3 times x minus 4. I'm going to join like terms. That's going to be x squared plus 4x plus 3 times x minus 4. Remember, if I'm going too fast, you can always change the speed or hit pause or rewind. So now I'm going to distribute this x throughout. So x times x squared is x cubed. X times 4x is 4x squared. And x times 3 is simply 3x. Now sending the negative 4 through. Negative 4x squared. Negative 4 times 4 is negative 16, then x. And negative 4 times 3 is negative 12. So I have my x cubed by itself. 4x squared minus 4x squared. Look what happens there. I have no x squareds. They cancel. 3x minus 16x is negative 13x. And my negative 12. So you can see this is one of those problems that if I started with this and told you to solve it with synthetic division, you would have to put a 0 in for the x squared term because it canceled out. Okay, 21, sketch a rough graph. Well, first off, notice this little 2 here. Okay, that means at x plus 1, so that's negative 1, it is going to bounce. So I'm going to put a negative 1 right here, and I know it's going to bounce. I'm also going to have a 0 at 3. So 1, 2, 3 maybe. And a 0 at negative 2. How about that? Now, why make your life difficult here? Take your calculator or Desmos on this problem. Go in here. There's no reason to guess on this. Go and put this in exactly as you see it. So I have a negative parentheses x plus 1 parentheses squared. Left parentheses x minus 3. X minus 3. Right parentheses. Left parentheses x plus 2. Close parentheses. Let's look at the table real quick. Check out my zeros. Positive 3, I got that. Negative 1 and negative 2, I got that also. All right, there are my points. I could get some other points if I want, like 0, 6. Okay, and everything else can be off the chart. So I hit graph. So notice how right here it came up through the -2 with a little jump and bounced off the -1, went up through the 6, 0, 6 we talked about, way up here, like I think it was like 24, and then back down through 3. No reason to get this wrong. So what's the degree? Okay, well, we just add up the multiplicities. So we have 2, 1, and 1. So it's a 4. Is it even or odd? That's even. The y-intercept, we said it, okay? You could plug 0 into all those parentheses, or you could just look at the y-intercept on the computer or calculator. 1, 2, 3, 4, 5, 6. There's my y-intercept, 6. Or you can put 0, 6, either way. What are the zeros? Well, we have -1, and that's a bounce. We have 3, and that's a through. And we have -2, which is a through. So I'm just going to recreate what I saw on the calculator. Little dip here, bounce up here, through here, somewhere way up there, way higher, and boom. It's a 4, it's even, and it's negative, so it should be the M shape. Now, it's not an even-sided M, but it is that general shape. Both are going towards negative infinity. And again, the test points are optional if you want to get a really specific graph. Otherwise, use a computer calculator to get the best picture you can. All right, next one. And we're just doing more of this. So we got 2 more. So for this one, I'm going to start off right away. I'm getting my calculator out or Desmos. I'm putting this in. I'm clearing this out. I'm putting x to the 3rd power. Don't forget, if you're using the graphic calculator, you've got to arrow down, so otherwise everything's going to go up here in the exponent. So minus 4x squared plus x plus 6. Okay? Right off the bat, I'm going to get an idea what this looks like. It's a positive cubic. Okay? Second graph. Where are my zeros? -1, 2, and 3. I know that right off the bat. I still have work to do here, but I know -1, 2, and 3. Okay? So, let's get back to the problem. Degree. It's 3. It's cubic. Even or odd? It's odd. Lead coefficient is 1. I already looked at it. I know it's going to be generally a positive cubic. So as I'm going left, I'm going down. And as I'm going right, it's going up. The y-intercept, I don't know. 2 things you can do here. You can plug in 0 for all your x's mentally or physically, which tells you right there what it is. Or you could also have gone to the y-intercept on the calculator and got it there. Okay, wherever 0 is for x, that's your y-intercept. Maximum number of turns, 3 minus 1, 2. Now, possible zeros. Well, possible zeros is P over Q. So that's 6 over 1. So that's easy. It's just plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. All the possible factors of 6. So there's 2, 4, 6, 8 possible zeros, and we're only going to have at most 3. All right? Factored form. Well, here's the beauty of it. You already know the answers. So since we just learned how to work backwards, you can do that right there. if we know the zeros, we can get the factors to prove it. But let's do synthetic division for practice and the way to get points on here, full points. So we know -1 is a solution. So I have 1, -4, 1, and 6. And here's the beauty of this. You already know what the other two answers are going to be when you factor this. So 1, -1, add, multiply, add, multiply, add. Boom. That's x squared minus 5x plus 6. Which factors to x plus and x minus. We need 2 times 3 is 6. All right. Actually, I lied. Since the end is positive, they're both going to be the same. And since this is negative, they're both going to be negative. So my factored form is x minus 2, x minus 3, and don't forget that x plus 1. The zeros, -1, 2, and 3, and they all go through or across. And to do a rough sketch of this, again, I have a point at -1. 1, 2, 3, 4, 5, 6. I have a point up here at 6. I have 2 and 3. So 2 and 3. So we know it goes through this, through here, and through here. How big the maximum and minimum are, you can look at your calculator and see, again, what it looked like. So I made this a little bit too big here, but it doesn't really matter. That's good enough. Oh, there was a place to graph it right there. Silly me. So here's -1. Here's 2. Here's 3. Here's my y-intercept. We saw that it kind of barely just went there. Little dip. And there. Sorry, I missed that. And last but not least, 22. So, degree 4. That's even. It's a negative, so we know it's going to be like an m, both going towards negative infinity. The y-intercept, plug in 0, you get -2. Maximum number of turns, 4 minus 1, that's 3. Possible rational zeros, well, here's my P, here's my Q, so 2 over 2. So it's pretty much plus or minus 1, plus or minus 2, and then plus or minus 1 over 2, and 2 over 2 is 1. So that's 2, 4, 6 possibilities, and we're going to have 4 of them. Not a lot of possibilities. So, factored form. Again, we're going to go to the calculator. We're going to put this in. We're going to go to decimals. We're going to put this in. Clear out. -2, x to the 4th, plus x cubed. Look what I did. I told you to watch out for this. I didn't do it myself. After that 4, I've got to go down here. Okay? I screwed up. But it happens. Plus x cubed. Come back down. Plus 6x squared. This is another reason why I use the square button here, so I don't have to worry about that. Plus x minus 2. And I'm going to hit graph to see what it looks like. That's about right. So I'm going to come here to my second graph and find out my zeros. -1 and 2. -1 and 2 are the only ones. I can't even find all of them here on there because they probably go through at a decimal or fraction. So -1 and 2 are all I have to start out with. So I'm going to do synthetic division. Okay, 2 we know is a solution. So -2, and then my cubic, my quadratic, my linear, and my constant. Since I know it's a factor, I should end up with a 0 right here. Drop the -2, multiply. Okay? Now, right now, I made a mistake, and I was going to start going. So watch. Don't write this down. 5. 5 times 2 is 10. That's 16. 32. That's 33. That's 66. That definitely is not 0. So I made a mistake. Where did I make a mistake? Well, I didn't pay attention to my signs, which happens. And some of you did this in the last test, and you didn't get 0 here, and you just moved on to the next problem. Pay attention. 2 times -2 is -4. That gives me -3 here, which gives me -6, 0, 0, 1, 2, and 0. So, -2 x cubed minus 3x squared, no x term, plus 1. Okay? Now, I alluded to this before. I could factor this, okay? Or I'm going to show you here, we know one of the other factors, right? We know one of the other factors was -1. Watch. I can do -1 right here in the box and do it again. So drop the -2. That gives me 2. Subtract. Multiply. Add. Multiply. I'm sorry, and add and get 0, which I should because -1 is a solution. Okay? Now, I start with a 4. This would have been a cubed. This is squared. So I have -2x squared minus x plus 1. So I'm going to factor this right here. That's a little more challenging because I have a -2 here and a 1 here. This obviously got to be 1 here. And I need -1 left over right here. So this is going to be, this gives me -2x squared. I need -1x left over. So this gives me -2x. And this will give me the 1x, -1x. Oh, my bad. Sorry. Yep. This should actually be plus also, because -2x plus 1x will give me the -1x left over. Okay? Now, here's the thing. Factored form. We had 2 and a -1, so that's x plus 2, my bad, minus 2. The -1 gives me x plus 1. Now this one's special here. Since we have a negative exponent, we got to pay attention to that. So we have a choice here. We can write -2x plus 1. Okay? I'll show you in a minute what else we could have done. And then x plus 1 here, there's my bounce. Now the other option would have been, if you want to put x minus 2, x plus 1 squared, and take the negative out and keep this positive. You could have done that also. Some people might do that. Okay? But there should be a negative in front of that. So, what do we do here? So we have a spot at 2. We have a spot at -1 where it's going to bounce. And we have a spot at this right here is 1/2. So this actually has a space for it, so we'll go with that. We said did we do the y-intercept on this one? Yeah, -2. So that's going to be right here. And again, looking at our calculator, see what it looks like. Boom. So it's going to come up, bounce off of this, come here, go here, and do here. Okay, and so lastly, I'm going to write my zeros. -1 is a bounce. 1/2 is a through or across. And 2 is a through or across. And that's it.